I wanted to know how fast you can make a model boat go, so I've scaled up my 3D printed hydroplane design and have been fitting it with larger and larger rocket engines to see what I can learn. I wanted to make the fastest boat I'd ever built, but can I get it to stick to the water, and is there a limit to how fast a boat can actually go? If you've watched last month's video, you'll know how hydroplanes like this one work, through skimming across the surface of the water on 3 low drag contact points. This allows them to travel much faster than conventional boats. My small design worked pretty well, but now I wanted to go bigger and more powerful to investigate some stability issues that I'd sometimes observed when the old design got up to high speeds.
Oh no.
So for the last month I've been experimenting with a test track, and yeah, it's been quite fun, and also I've found some pretty interesting results. And obviously I've gone way overboard and completely overpowered this thing with some really big engines. Firstly, I scaled up the boat on CAD and then got to work printing out all of the parts I needed for the build. This boat is twice the size of the previous boats I was playing around with in the last video, which should help with stability and dealing with small ripples and waves at high speeds. I assembled all of the pieces and then painted the whole thing and spray sealed it, which would make it quite waterproof. You've seen this all before, so what engines was I going to be using? I decided to use engines with short burn times of just a second or two for these experiments. These can be bought from model shops and are intended for model rockets. They're electronically ignited and work through burning a propellant which contains an oxidizer. I plan to start small and work my way up, adding more and more rocket engines to increase the total thrust of the boat. Great plan, right? I mean, look how cool this looks. Well, actually no, this wasn't such a good idea to do it just like this. This is because igniting so many engines at once can be quite problematic in terms of reliability, so I thought I should do a test.
Right, let's see if we can get all of these things to ignite at the same time. Big safety disclaimer, by the way, don't do this at home, and also don't do most of the things I do in these videos. You'll be pleased to hear I'm taking this very seriously and taking lots of safety precautions.
Yeah, that didn't work too well, as clearly one of the motors didn't go off.
These engines went off, but the final 5th one didn't, so that would suggest that maybe 5 is too many for a cluster rocket configuration.
So I settled on these engines to do 3 tests, starting with a single D-size engine with about 3.4 kilograms of max thrust. And yes, I measure thrust in kilograms. So what benchmark speed could we get with just one rocket motor? Well, firstly, I had to wait for a good test day, which is easier said than done at this time of year.
Believe it or not, this is the best day I had to do this experiment, so yeah, let's make the most of it.
The track I assembled was just a couple of lengths of guttering filled with water. To accurately measure the velocity of the boat, I stuck up these reference squares and pointed a high-speed camera at them. At the end, I piled up some snow to catch the boat, and yeah, you're about to see how well that would work. So the big question, how stable would the boat be, and would it remain in one piece?
Arming circuit. 5, 4, 3, 2, 1, ignition. Wow, that really bounced along.
On that first run, the boat got up to an eye-watering 10.6 meters a second, or 23.7 miles an hour. So it was time for more rocket engines. However, back in my office, when warming up and watching the footage back, I'd noticed that the boat was jumping along quite a lot. This was probably caused by a low overall angle of attack of the boat, with it nosing into the water. So I made use of the adjustable sponsons and angled them slightly to have a more positive angle of attack and also just raise the nose up a bit. Now to double the power with 2 of the previous rocket engines. Would I get reliable dual ignition though? And what else might go wrong?
Fire!
Well, the first problem I had was I'd failed to ignite both motors at the same time. What a surprise. And yeah, the small second problem was that the boat was actually on fire.
Whoa.
Yeah, this is exactly why you never go back to a rocket that hasn't gone off.
Oh, disaster.
What happened here was that the second motor decided to spontaneously combust due to the heat and flames of the first motor. So that was it for that day, and now I needed to reprint a motor adapter and reload 2 fresh motors to rerun the test.
Right, chaps, we're going to go for launch in 5, 4, 3, 2, 1, ignition. Wow, that was a lot faster. That was a lot faster.
Test 3 had shown that doubling the thrust actually more than doubled the boat's velocity through the measured section to 22.7 meters a second, which doesn't seem to actually add up. But upon closer inspection, it might be due to the fact that the boat wasn't actually in full contact with the water anymore, which was a bit of a problem. Here's the thing about high-speed boats: they travel within a Goldilocks zone of stability. If the boat hits a small wave or disturbance, it could flip as a critical amount of air gets under the hull or submarine as the boat enters a resonance that results in it diving beneath the water. I think what the previous test shows is that I needed to press the nose of the boat into the water a little more, rather than having a high up angle of attack. So I adjusted the sponsons again just a little to reduce the angle of attack of these critical points. I tried to rerun the tests again, but I was struck by some more unreliability from the dual motors, which resulted in this spectacular crash. So I thought maybe it's time to move on to something even more dangerous. Now, what happens when you double the power again by straying into the territory of mid-power rocket engines? This is a pretty big engine to have on a boat, let me just say that. Before I show you what happened on the final test run though, it's time for a quick ad from the sponsor of this week's video, CuriosityStream. CuriosityStream is a subscription streaming service that offers thousands of documentaries and non-fiction titles from some of the world's best filmmakers, including exclusive originals. If you want to watch some great documentaries about science, engineering, maths, history, and so much more, this is the streaming service that you need to try. A documentary I've been watching recently, which involves all of those things above, is this one on Neil Armstrong, who is one of my big heroes, as you might expect. CuriosityStream is for people who want to know more. It's available on many platforms and is extremely affordable at under $20 a year, which is just $1.67 per month. There's so much on there and there's new shows added every week. Make sure to go to curiositystream.com/projectair for unlimited access to the world's top documentaries and non-fiction series. And for you, as my viewers, use the promo code PROJECTAIR and you'll get 25% off. So yeah, click the link below or go to curiositystream.com/projectair and save 25% right now. That's only $14.99 for the whole year, which is just $1.25 per month. Thanks very much to CuriosityStream, and now yeah, on with the rest of the video. I was actually quite nervous about this engine because when you get this big, they're very noisy and quite intimidating. Sticking one of these in a boat didn't really seem right either. Here's what happened. 5, 4, 3, 2, 1. Whoa! That was very loud. So what speed was that? Well, faster at 30.3 meters a second. But unfortunately, the old issue of the boat deciding to become an aeroplane had reappeared. The next step is to continue testing and maybe try some radical solutions such as active aero. Perhaps there is a limit to how fast a boat can go without something like that to keep it perfectly balanced at all times. Anyway, this has been lots of fun and I'd learned lots which will be useful with future hydroplane builds. If you'd like to see some more things that I've made, then click on one of these videos over here. I think you'll enjoy whatever's in the one that you click on. So yeah, I will see you then.